A rainbow, like this one behind me, is one of the most impressive light shows here on Earth. But how do you see one, and what are they really? Let's find out together in this episode all about the behavior of light. It just finished raining right here where I am, and I'm pretty sure it's still raining back there behind me, because there we have a beautiful rainbow. We're lucky enough to observe this optical phenomenon due to light. What is light? Light is the movement of energy through space. The energy of light waves travel through mediums such as air or water, or even travel in the absence of a medium, like a vacuum. A medium is just some type of matter. Light energy is composed of electric and magnetic fields that travel perpendicular to one another. That is why another name for light energy is electromagnetic radiation. A scale known as the electromagnetic spectrum was designed to classify waves by their size. You can learn all about it in this video. Light travels in a straight path until it comes in contact with an object. So what happens when light hits an object? When light rays come in contact with an object, they can either go through it, get absorbed, or bounce back. So when light hits an object, it's either transmitted, absorbed, reflected, or refracted. The determining factors between results are things like the energy of the light wave and how molecules are arranged in the receiving material. What is most interesting is you can have different wavelengths of light interacting in different ways. Some could be reflected, others absorbed, or transmitted. This is where we get the color of objects. Reflection occurs when a ray of light moves in one direction, hits a surface, and then moves back in another direction. Or in other words, reflection is when a wave bounces off a surface. The law of reflection explains that waves get reflected in a particular way. A wave will reflect at the same angle as the angle that it moved toward the barrier. So, if a ray of light moves toward a wall at 45 degrees, it will also bounce off and travel away at 45 degrees. You may already know that reflection is what allows you to see yourself in a mirror, or even in the calm surface of a puddle. But reflection is much more than that. Looking here at this leaf, what color of light is being reflected off of the surface? Since our eyes see it as green, we are getting a reflection of that green light. Reflection is what allows you to see every object that doesn't produce its own light. Let's take a quick look at this laser maze. You can see the source of the light here. The laser then travels in a straight line until it bounces off this first reflective surface. We can see the law of reflection in action. The light is traveling off at the same angle, just in the opposite direction. Then the same thing here, and again here, until the light reaches the target. If a wave passes through a substance, absorption may happen. The other option is the light could be transmitted or granted passage through the medium itself. Absorption is the transfer of energy from wave to matter as the wave passes through it. For example, waves of light from the sun enter the ocean, and as they travel down, they are absorbed, which is why the deeper you venture, the darker the water becomes. Some substances only absorb specific wavelengths. This is how we see color. Back to our leaf example. We said that the green light is being reflected, which is why we see the leaf as green. So then what light is being absorbed? It's pretty much going to be every other color of the visible spectrum. Simply put, types of chlorophyll in plants love absorbing bluish-purple light and reddish-orange light, but not green, which is why chlorophyll is green. Plants use all that other absorbed light for photosynthesis, which is a whole other episode. When light rays are absorbed, they are transformed into a different form of energy, such as heat. This is why colors that absorb more light rays, darker colors, heat up in the sunlight. We can see this simply with different colors of construction paper out here in the sun. After a few minutes, we use this infrared thermometer to measure the surface temperature of each color. Here are the results. As you can see, as we move along the different colors of construction paper, the darker colors are absorbing more heat. If you're still here liking this video, let us know and hit that subscribe button so you never miss an episode. Looking at this arrangement, where is the transmitted light? It's going to be right here on the top. Where would we look to find the absorbed light? As the light travels into the gummy bear line, some of it is absorbed by the gummy bear itself. And then the reflected light is going to be right here on the front of this first gummy bear, bouncing back where it came from. So each of these gummy bears are absorbing and transmitting a different amount. When I point the red laser through the red gummy bears, the red light passes through or is transmitted. But when I point the red laser through the green gummy bears, the light does not pass through. This is because the red light is absorbed by the green gummy bears. A green laser through the green gummy bears, the green light passes through, but not through the red gummy bears. The green light is absorbed by the red gummy bears. Now, I can eat these. Refracted light waves are similar to transmitted waves in that the light exits the material on the opposite side. So light is still traveling through the medium. Refraction is when light bends when it travels from one medium to another. The light rays change direction because the speed of light changes, and this causes objects to appear distorted. Refraction can be observed here with a simple glass of water and a popsicle stick. As you can see, it appears that the popsicle stick bends at the barrier between air and water. Remember, refraction is caused by a change in the speed of a wave of light when it moves from one medium to another. It's kind of like riding your bike on smooth pavement and then suddenly rolling over to sand. Your bike is going to slow down. The same thing happens with light. When light hits a more dense medium, it's going to slow down. Rainbows are a combination of reflected and refracted light. This occurs when sunlight spreads out into its spectrum of colors and is diverted to the eye of the observer by water droplets. Let's look at the path of sunlight through a single round raindrop. As light enters the raindrop, air to water, it is refracted and slows down. Each color of light bends at a different angle. The refracted light reflects off of the curved, internal, mirror-like surface of the raindrop. The light refracts again as it travels through the front side of the raindrop, water to air, speeding up, making a beautiful rainbow. The raindrop is circular, so the reflection that it creates is also circular. But unfortunately, we don't see a full circular rainbow because the Earth gets in the way. The next time you see a rainbow, just thank the behavior of light. And if you want to learn more science, you can check out this video next.